So now that we have a sense for one reason why we might care to know what a matrix is, we can start talking about how to construct them, what they are, and specifically what an augmented matrix is. But before I do that, there's one thing that I feel I have to get out of the way. Now then, when we're talking about a matrix, what we're looking at is something kind of specific. It's the wording for the definition, as I'm kind of stumbling with my words here because there isn't really a nice definition for it. It's a construction for describing certain types of things. In particular, the book defines it as a rectangular array of values, where those values are called elements, organized into rows and columns. So when you're thinking of a matrix, don't necessarily think of the definition or Keanu Reeves for that matter. Instead, think of a picture like this, where you have those values there in a specific arrangement, where those values are the elements of the matrix, and the whole picture in that setting with the brackets around it is what makes a matrix. And I'll just say that this book, for whatever reason, is picky about its notation for referring to matrices here with brackets. Sometimes you'll see them with parentheses. It really doesn't make that much of a difference, whichever you use, as long as you understand roughly what kind of thing you're looking at here is that rectangular shape in space with its elements. And in particular, when we're looking at an augmented matrix, at least for this section, what we're thinking of is a representation of a system of linear equations. Specifically, we're talking about an arrangement of coefficients. So when you're thinking about an augmented matrix, what you should really be thinking about is the system that it comes from. Think about a picture, something like this, where what we have to work from is coming from a system, like what we have there, and we identify all the pieces in that system, all the coefficients in that system, pull them down and organize them. So rows correspond to equations, columns are where the coefficients come from, and then to specify that we're doing an augmentation here, we sometimes, in this class in particular, will draw that vertical line down between where the equality is, that is the constants, and the variable terms in terms of our system. Where, to be clear, if we have a coefficient of 1, like say we have an x term by itself, we put in a 1 in its place in the matrix, and if we have nothing, like say one equation is x plus 4y and the other is just y, then there has to be a 0 in the x's term. But we'll see what this looks like a little bit better with some examples that we're going to get to next.